If operation research is in your syllabus, then the transportation problem is not at all optional. It's guaranteed. And once you understand the basic clearly of transportation problem, half the problem is already solved, right? Most of the students, they came to me and they say, sir, matrix देखते ही confusion हो जाता है. In this video, I'll make sure that confusion will never come back again to you, right? Hello everyone, welcome back to my channel Decode Data with SKD. Let me ask you a simple question, right? Do you really feel that finding the optimum solution of a transportation problem is difficult? And I'm sure that your answer must be no. Yet, when you first look at the transportation problem, it still creates confusion and number of doubts. You start wondering, what does this matrix actually represent? What is the first step to solve it? How to move from this matrix to a valid solution? I'm asking this because transportation problem is a core topic in operations research, and they appear very frequently in university or competitive exams. And the ultimate goal of any transportation problem is to find the optimum solution, because again the transportation problems come under the operations research methodology. So the same, we have to find out the optimum solution, right? To find the optimum solution, the concept of initial basic feasible solution become very important. And you can think of IBFS as a foundation that leads us to optimization. So in this video, I will begin with a clear introduction of transportation problem. So I'll tell you what exactly a transportation problem is. Then I'll move step by step into the concept of IBFS, how to get the IBFS. It means initial basic feasible solution. After this video, you will understand why IBFS is required, first of all, what it represents, and how it guides you towards the optimum solution, right? So because it is very important for optimum solution, so you have to understand how to find out the IBFS and what exactly IBFS is, right? In next 5 to 10 minutes, I will explain everything in simple, logical and exam friendly manner. So even if this is your first exposure to transportation problem, you will feel very comfortable and confident, that I'm sure. Watch this video till end, because once IBFS is clear, advanced method like LCM, NWCM, VAM, Modi method will automatically start making sense for you. All right, so let's begin. Now let me just explain first of all what exactly the transportation problem altogether, right? Now let's take a simple example. I have 3 factories, right? Factory 1, factory 2, factory 3. So 3, 4, 5, anything. So I have 3 factories in different locations. So one might be in Bangalore, one might be in Hyderabad, one might be in Delhi, right? And because I have a factory, so factory will have some certain production, right? So production will be say S1, S2 and S3. So factory 1 will produce S1 unit, factory 2 will produce S2 unit, and factory 3 will produce S3 unit, right? So this is what basically the production that I have, fine. Now, because I am producing something, I have to sell into the market, so I have a warehouse also. So let's say 3 warehouses, warehouse 1, 2 and 3. I have taken 3, you can take 3, 4, 5, anything. Any combination of number of factories and number of warehouses, right? So warehouse 1, 2 and 3. This might be again a different location, Vizag, Mumbai, Hyderabad, something like, right? And because these are the warehouses, so warehouses always have a demand of a product from the factory, right? So we'll say demand 1, demand 2 and demand 3. So every warehouse will have certain demand, whatever it is, based on whatever the production is. This is a common sense, right? Now, whatever we will produce in the factory, we have to supply. So we'll say it's a supply. And because warehouse wants something, warehouse is having a requirement, so it'll say it's a demand, right? Now, factory 1 can supply to warehouse 1, factory 1 can supply to warehouse 2, factory 1 can supply to warehouse 3. Same way, factory 2 can supply to all 3, factory 3 can supply to all 3. So this is what the combination altogether is. Now here the important thing comes. When I have to supply something from one factory to one particular warehouse, in this particular case, I have to pay the transportation charges, right? Now in this entire system, what I have to do is, being an operations manager, I have to find the cost that should be minimum and all the material will be transferred from one place to another place. This is what my challenge is, right? So being an operations manager, my challenge is what? My transportation cost should be minimum, that is normally known as optimum cost, and all the product will be transferred from one place to another place. Clear? So this is what the situation is. Now, for this particular situation, we have 3 different methods. One method is called least cost method. Second one is called northwest corner method. Third one is called Vogel's approximation method, and normally sometimes people say penalty method also, but normally calls Vogel's approximation method. So these 3 methods are there. And what these 3 methods will do, these 3 methods will take you to the initial basic feasible solution. Now you have to understand here what exactly initial basic feasible solution is. See, whenever you have a problem, right? So problem will have a solution or not. So either a problem is having some solution or not. So you'll say, I don't have any solution to it. Yeah, or you'll say, I have a solution to it, right? So when you say a problem is having a solution, means you are talking about feasibility of a solution, right? That's why it's called feasible solution. Now, why it is called basic? Because what will happen is your job as a operations manager to find the minimum cost. That should be optimum, right? Minimum means optimum cost. Nothing less than that. That is the minimum, right? But these 3 methods will only give you the basic cost. Cost means you are not sure whether this cost is optimum or not. So that's why it's called the basic. And why it is initial? Because this is the first you will get once you will solve with the help of any of these 3 methods. Clear? Now, when you have a initial basic feasible solution with you, now you are not sure whether this is optimum or not. So if it is optimum, it's fine, right? You have to check whether it is optimum or not, right? If it is not optimum, then what you have to do is you have to convert this into optimum. So this is what the entire process is when you are talking about the transportation problem and want to find the cost, that is optimum cost, right? So first of all, you will go for the initial basic feasible solution. Then you will check whether this is the optimum or not, right? So this is optimum or not, right? If it is optimum, job is over. If it is not optimum, then you have to convert this into optimum. Simple. Clear? So hope up to this point things are clear. Now let me just take you through the type of matrix we'll define, right? Fine. So in this case, I have 3 factories, F1, F2 and F3, right? I have 3 factories, F1, F2, F3, and I have 3 warehouses. Sorry, we have 4 warehouses, right? So you can have any number of warehouses, right? And every factory will have some supply. So all 3 factories will have some supply and all the warehouses will have some demand, right? That's why the demand is mentioned here and the supply is mentioned here, right? So let's see. Factory 1 is producing 11 unit of whatever trucks. Factory 1 trucks, right? Cars, whatever it is. Factory 2 is producing 13 units and factory 3 is producing how much? 19. If you club this all together, the total supply from all these will be 43, right? 11 and 13, 24, 24 plus 19 is 43. Now, same warehouse will have a demand of 6 because depending upon the capacity. Warehouse 2 is having a demand of 10. Warehouse 3 is having a demand of 12 and warehouse 4 is having a demand of 50. So now you'll see 6 plus 10, 16 plus 12, 28 plus 43. So the total is 43, right? This is what 43. So my supply and demand is matching. Whatever I have to, whatever I'll produce, I will deliver to warehouses because they have a same demand, right? Now, suppose I will deliver from factory 1 to warehouse 1, right? Now, in this case, let's say I have to pay 16 rupees per unit, right? So suppose I'll say 10, 16 into 10, 160 rupees I have to pay to transfer 10 units, right? If I have to go for factory 1 to warehouse 2, factory 1 to warehouse 2, 21 units. Then this is factory 1 to warehouse 3, and this is factory 1 to warehouse 4, right? And of course, cost. So this cost is basically per unit cost, right? 1 unit transfer of 1 unit needs, you have to spend this much of money to transfer 1 unit from factory 1 to this, right? Clear? So now for all factory 2 to factory 1 and all, we have certain cost, right? And the total is 43. Now this is what the matrix is, right? Now this matrix is known as the transportation matrix. And your job will be to find the initial basic feasible solution with the help of 3 methods. Once you have that 3 method, then you have to check whether your solution is optimum or not. And if your solution is not optimum, then you have to convert it to optimum. Fine. So I hope this is clear to you all. I request you to please hit like button, subscribe for more easy explanation, comment your questions and share your thoughts. I will try my best to give you answer for all the questions that you have. And yes, don't skip the next video on LCM method, right? I'm going to share soon one video on LCM so that you will be able to understand how we will apply LCM to find out the initial basic solution. Thank you very much for watching this video. See you in the next video. Have a nice day.